Hey everybody, Mrs. Bianchi. We're looking at question number 5, which is a little complicated, but we'll break it down and try to make it as easy as we can for you. It says, the figure shows the dimensions of a lidded bin. Can the expression below be used to find the surface area of the bin? Explain your reasoning. And then we have to choose, which one of these situations we're going to pick. So let's try to identify each dimension and see if we can find an expression that could be used to find that. So let's take the floor of this thing for starters. Now that, even though it kind of looks like a parallelogram in the image, this is actually a rectangle. And if we were going to find the area of this, wouldn't we be multiplying 8 times 7? So I see that right here in the lineup, and that's appropriate. We would find 8 times 7 and we would add it to other stuff. So that's like, I'm just going to put a check that, that justifies this aspect of it. Now, what about what I'm going to call the right side? Let me highlight that. How about in red? So let's take a look. The right side, that's this piece. Also a rectangle. So if we were interested in finding the rectangle, wouldn't we be multiplying 7 times 5? Now I see a 7 and a 5 being multiplied together right here. So that justifies that piece right there. All right, let's erase that so we don't get confused. Now what about this back piece? I'll highlight it in green. Also a rectangle. Also a rectangle. Now, the dimensions of that, remember, if this is 7 here, if that piece is 7, then that means that this piece would be 7 back here. So if we were interested in finding that, wouldn't we be multiplying base times height, or 11 times 7? So I do see that right here. The idea of that covers that back piece. All right, let's erase that and move that out of the way. Now, we haven't covered, what we might call the lid of this thing. So how about I use purple for that? This part. Another rectangle. It's another rectangle. So to find the area of that, wouldn't we need this line, which earlier we said was 7, right? Because if this is 7, that means this is 7. And they tell you that it's a 7 by 10. So that's consistent with what we see right here, right? That covers the lid. So now what we really have to do is we have to focus on this part, because it's mentioning that we have 2 of something, and that would be true. Let me erase this. We do have 2 of something. Let's erase that. And we have 2 of these. We have this piece right here, and then we have the one in the back. So that's consistent with having 2. So the 2 part's right. But what about this part? What about the half times 6 times 8? Let me move this out of the way. Now, half of 6 times 8, that kind of looks a little bit like a triangle, doesn't it? The half times 6 times 8. So if we decompose this thing into this triangle, I didn't really draw that very well. So we have this triangle here, and then we have another one back here. Would the dimensions of that thing be what they're saying here? So in other words, this would be 8. If this is 8 here, then this piece is 8. So that would be the base of the triangle. And when we're figuring out the height of this thing, this line right here, we know that the whole thing is 11. And if it's 5 from here up, so let me move that over. So that means that this is 5. That means that this piece is 5. So all the way around would be 5. So 5 plus what equals 11? That would be 6. So we do have that idea of 6 being multiplied with 8 and taking half of that to find the triangle. And that would cover this piece back here. But what's missing? Have we included this part down here? So let me do that in a dotted. Have we included this with this formula? Because that would also be missing here, wouldn't it? Do we have that in there? Look at the answer choices and decide which answer choice shows that.